Right, yes, your famous Lambda benchmarking across the various languages and runtimes.
Lambda benchmarks, yes. Yeah.
Yes. Very cool. Chan and Shilpa, feel free to say hello. Just a quick warning, we are live on YouTube now, but I'll chop off the start of the general chit chat of the meetup. So yeah, don't worry about it. If you feel free to say hello. If it's a bit too awkward, it's totally cool. I'm by the way, king or master of awkwardness, so you'll never top that one.
Yeah, hello everyone. Yeah, I'm Chan. Yeah, nice to meet you all. Yeah, exciting to look at the serverless. Yeah.
Yeah, whereabouts are you based, Chan? Are you based out of Sydney or a bit more further afield?
Yep, I'm based in Sydney.
Yeah, cool.
And I'm also a part of the I'm part of the Deloitte, Australia.
Yeah, cool.
So Chan and Shilpa are both from my company.
Awesome.
Yeah.
So Chan is in the cloud engineering team, and Shilpa is actually with me in platform engineering.
Yeah, I'm for the engineering teams with the DevOps. So yeah, I'm very interested in the learning all this serverless.
Hi guys, I'm Shilpa. I'm also like we're here to support Yun with this talk and then extract how much of possible from his head and learn more on serverless. Really excited to be here.
Thanks, Shilpa. Well, welcome, Chan and Shilpa.
Welcome.
Thank you.
If you would like to keep an eye on proceedings on YouTube, I will send you a link now to share with your friends. For the speakers, I always find it's quite distracting, almost disturbing, to be fair, if you try to listen to yourself on a live stream on YouTube with a 30-second delay. Yeah, it's not the easiest thing in the world to sort of keep track of. So now. Okay, we're getting a few more folks on the line. I'll share my screen real quick pretty soon. And we'll get it underway once a few more folks have joined. Hey Rowan, we were just talking about you before, or has he dropped off?
Oh,
yeah,
Dave has joined us as well. Dave is another one of my colleagues. We're showing up in force.
Nice. Welcome, David.
Hi, thanks, guys.
Welcome, Dave.
Thanks, Ewan. That photo isn't how I normally dress when I'm working from home.
I think we're all going to have a tough time adjusting to working back in the office, like getting dressed appropriately in the morning and things like that.
Or even just getting up in the morning.
Yes, there'll be a few visits to the dry cleaners. Get the suits out and dry clean them.
Yeah, and it's a good point, David. We'll have to probably stop watching so much Netflix in the evening and go to bed a bit earlier in order to make the train ride into the city or something like that. That's definitely for me. That's for sure.
I don't know about everyone else. I'm seriously, I'm running out of stuff to watch. It's just been binging.
Definitely. Cool. Well, I think, Aaron, you've got to, you're actually doing a workshop pretty much directly after this, aren't you? So we probably better get a move on.
I suppose we can. Should probably open my slide deck and things like that. Whoa.
Yeah.
Something just broke. So let's not do it right now because things have just gone boom.
Okay. I will just share my screen though in the meantime.
Yeah, do your introductions.
And hopefully you'll be back on deck.
Yeah, no, I know what I did wrong. It's all good.
Oh, I can see one of my friends, Gerald, has joined. Hey, Gerald.
Cool. We'll be going on mute pretty soon, folks, just so that we can allow our awesome speakers to chat and do their thing uninterrupted. But in case you didn't realize where you were, we're at the Sydney Serverless Meetup. My name's Peter Hansons. I've got Aaron Powell and Yunji Lin here with me. They're going to be taking us through some really awesome presentations. Aaron's going to take us through, I guess, some more complicated GitHub Actions workflows, which is really cool. I'm personally having a lot of fun with GitHub Actions at the moment. It's just so easy to use, and you don't have that, I guess, setup overhead that you do with other CI/CD pipelines. So really excited about that presentation. And then to cap it off, we've got Yunji Lin. He's recently moved across to Deloitte. So it'll be interesting to hear from him about that, and also to find out about Lambda Containers. So recently at reInvent, actually, was it pre-invent? I don't recall. But yes, Lambda Containers was announced. There seems to be a lot of different ways you can run containers on AWS these days, even with, I think you can run containers on Lightsail these days. So there's lots to unpack there, and I'm sure Ewan will do a really great job of taking us through all of that. So very much excited by that presentation. But without further ado, I will let Aaron take it away. Let me just make sure you can share your slides, Aaron. Did you want to give that a go?
There we go. And now we got to work out which screen is it calling which screen. There we go. Excellent. Cool. So I'm going to assume everyone can see my screen and all that kind of stuff. It's usual sort of webinar start. Can you hear me? Can you see my screen? Is my camera on? How do I look? Is the lighting all right?
Amazing.
But yes, as introduced, I am Aaron Powell, and I'm going to be talking about creating release pipelines with GitHub Actions. For those of you that I haven't had a chance to meet in person or at least see at a virtual event, hi, welcome to Serverless Sydney. My name's Aaron Powell. I work for Microsoft. I'm part of the cloud advocacy team. I've been doing web development for sort of 15, 16 odd years now. And in my time, I've probably deployed a website in pretty much every way, shape or form, from network shares where we were just copying the files across to getting more advanced tools like FTP and then maybe an SFTP because we wanted to be a little bit secure, to starting to do automated processes with Travis CI when that became available, Circle CI, cruisecontrol.net, TeamCity, Octopus Deploy, and obviously Azure DevOps. I have used that on a number of occasions for building deployment pipelines. If you want to get in contact with me after the session, you'll find my details there. I tweet random things that are probably not of major relevance to most people's lives. But you can also find my blog. If you want to reach out via email and ask any questions or anything that I don't cover in this session, please feel free to do that. Yeah, I'm more than happy to answer questions as we go along. But that's enough about me. You didn't come here just about me and my background, my history, and all the things that I've done in my career. You've come to learn about GitHub Actions. Also, just for everyone's convenience, I've put QR codes on all of my slides that have links to them. So don't feel like you got to frantically screenshot or type out a link that's there. The QR code's there, so you can obviously scan that with your phone or anything else as we go along. But GitHub. So yeah, we're talking about GitHub Actions, specifically the Actions version 2. That's what we're going to be covering off today. But just to make sure that we're all on the same kind of level playing field, I want to talk a bit about what GitHub Actions is for those of you who haven't had a chance to look too much into it. GitHub Actions is a way to create workflows that will run some sort of an automated task from events that happen within inside of a GitHub repo. Now, I'm going to be contextualizing this around the kinds of deployment actions that you might want to be doing and the sorts of events that might be triggering the need for a deployment, pushes, tag creation, that kind of stuff. But events can be a lot of different things. It could be when someone applies a label to an issue. It could be when a new contributor is added. It could be a manually triggered webhook. So if you'd ever worked with GitHub webhooks in the past, they're basically all the events that are available behind the scenes that you can use from a GitHub Actions workflow file. So ultimately, this is just creating some way to do a response to something that's happened on your repository. And it will happen in the context of your repository and the user that has triggered that particular action. And from a terminology standpoint, GitHub Actions is the kind of the product that we're looking at here. A workflow is the thing that's run, and then jobs are things that happen within inside of workflows. It gets a little bit confusing, and I always tend to just call it GitHub Actions, but GitHub Actions is kind of this overarching thing. Workflows are sort of more like what we probably should be referring to them as. Things are confusing, as they always are. So a workflow is going to run a series of steps through to completion of whatever the task there might be. This can be steps such as running a shell script. So if I might be doing like an npm install or another command line task. It could be running an action that's been provided by a third party to maybe create a release against a GitHub repo. It could be updating an issue with a particular label, or it could be calling out to some kind of a third-party API. Maybe we're doing a deployment into a cloud provider, or we're calling out to some other system that we need to do some updates in. You can create your own tasks quite easily with GitHub Actions. They are written in, you can either write them in JavaScript or TypeScript and they get compiled down and run via a Node.js task runner. Or if those aren't your languages of choice, you can write your own, deploy them as Docker containers so that you can then kind of write whatever language you want to write. You could write it in Go or Rust or .NET or any of the n number of languages that are out there. These are then run by either a self-hosted runner that GitHub manages and has a bunch of pre-installed software on it, or you can provide your own task runner. So maybe you've got something inside of like a DMZ that you want to run. You can put those, you can have those task runners that exist within inside of your environment that you control and you manage how they what's installed on them and how they operate. So this can be used for CI/CD tasks, so your traditional continuous integration, continuous deployment tasks, but it's essentially just a YAML file with a series of sequential steps that you start at the top, and it's going to execute all of those until it gets to the bottom. This is the example. This is an example of a GitHub Actions workflow file. This is what I use to deploy my website. My website is a static web app. So I use Hugo as the generator for that. It's going to generate a bunch of HTML and CSS files and a bit of JavaScript, some little WebAssembly stuff that kind of lives in some experiments I have on my website. So they all just happen within inside of the stages that go through, the jobs that happen within inside of this workflow. This is obviously a very truncated version of it. It's going to be much more complex than that. And I couldn't fit that all on a slide and actually have you see what it means. But if you've worked with kind of any YAML-based deployment tools, the structure is probably fairly similar. There's like some metadata around it, name, environment variables, the events that are going to be triggering this off. So this is a push to a particular branch or a pull request against a particular branch. And then what are the jobs that are going to be done? They're named. This is the Hugo job that we can see at the start. Gets the source code. It's going to then work out what version of Hugo to use, grabs an action that has Hugo inside of it, so on and so forth. And then inside of GitHub, we see something such as this. This is an execution of a successful execution of deploying my website. We've got a number of jobs that happen. Some of them happened in parallel of each other. So I have a search UI that's actually written as a WebAssembly application and the static website content. So they run in parallel. It builds a search index and finally deploys that out into where I host this on Azure. We have some jobs that don't get run because of conditionals that got checked. So that's why in the left-hand side, you'll see a closed pull request job that never got hit because, well, this was just a push to the main branch. It wasn't to deal with a pull request. So this is, we can start seeing how we can build something a little bit more complex, a little bit more like what we would be doing to deploy an application out. And it's not just responding to an arbitrary event to update labels and issues. It's trying to do something a bit more complex with our deployment pipeline. You can, again, you can check out these through the links. I'll also put the links out on Twitter and tag the Twitter account for Serverless Sydney. So if you don't screenshot or don't grab the QR codes, you can get them later off social media. Okay, so let's think about how does a release process work? For my website, I will just quite happily push to main branch and that will get deployed, and I realize I did something wrong, and then I'll just push to main branch, and then you'll see a lot of commits going fixing DevOps. And I'm sure that no one else has ever had to write a commit of just it's just mashing the keyboard because you just need to trigger a new build. No one does that, do they? Of course not. But there's a lot of things. So there's a lot of things that we can do with GitHub Actions. But yeah, let's contextualize it around how we could do the kind of release process that you would have for a proper product, not just a personal blog. So let's think about the sorts of things that we would have in there. Well, we'll have an event that's going to happen, push to a particular branch, a tag that's been created or whatever it might be that indicates that a release is going out. We're going to need to build our source code so that we can get that releasable artifact that's going out to wherever it's going out to. We then probably want to wait for some sort of approval just to make sure that this was a valid push. We're not just because a push got made to the release branch. Well, that just means it goes straight through to production with no checks along the way. We just rely on everything being automated. Maybe we do have a stage gate of just whether it's a smoke test on a previous environment or whether it's just, actually we did need to push that release out. We want to wait for some kind of approval. And then that's where we release to our target environment. For a long time, this was actually really difficult with GitHub Actions. In fact, there was no way to do this, this third step, the wait for an approval process. I actually wrote a blog post about 12 months ago around how you could do this by leveraging issues in GitHub. So what it would do is, because it was just running top to bottom in that YAML file, there was no way to tell it to stop somewhere. So you had to split it up over multiple individual GitHub workflow runs. So what it would do is it would create the releasable artifact and then create an issue in GitHub that would then be labeled a particular way. You would then come in and put a different label on the issue and put a comment, and then that would trigger off a different workflow file. And then that workflow would run by looking at that issue, pulling out some metadata that would have been annotated in that issue to try and work out which was the build that had triggered it to get the artifact. And it was held together by kind of my hopes and dreams of writing a blog post about being able to do this. And it wasn't really scalable. It wasn't something you could drop into a lot of projects because it required a lot of custom actions. It was very much designed around the way that repository worked. So it was not, it could be done, but it wasn't really ready for what I would consider prime time usage by most people. At the end of last year with GitHub Universe, they released a new feature called environments, or more accurately, they expanded on a feature that was already kind of in GitHub, which was called environments, but it was not really related to the way actions worked or anything like that. It was just sort of this other thing that sat inside of there. But environments were brought in to make it easier to do this sort of stuff that we're talking about here. So an environment is something that you define as part of your repository. It's not tied to a workflow file or anything like that, but it's independent of what your actions are doing and the builds and stuff like that. It's just yet another thing that's inside of your GitHub repo. So the advantage of this is that because it's not tied to a single action or a single workflow file or anything like that, you can use it in multiple locations. It's got its own set of information. So it's got its own secret variable. So if you've got like an API key or like a database connection string or something like that, and you're doing a staging production sort of like multi-tier environments setup, well, you don't want the production to have access to the database connection information for your staging environment and vice versa. So you can put that inside of a specific environment. So only that environment has access to it. You can then define protection rules. And this is really where we kind of wanted to get to and want to be able to do this sort of smoke testing along the way, is have protection rules on the way that an environment can be used. So there's two primary protection rules that we've got. One is that you can define a approver for that environment. So this is just who can allow something to get into that environment. You could have up to 6 approvers defined per repo, and any of them just has to essentially approve. Like you give it the thumbs up or thumbs down, and that defines whether or not that environment can be used for a GitHub workflow to do its next things. The other kind of protection rule you can have is a timeout. So you can basically say that you will not be able to deploy to this environment, or you won't be able to do something against this environment until n number of minutes have passed. I think it's like 30 days or something is the maximum timeout you can set, which is kind of crazy. I can't really imagine why you'd ever need to do that, but you can do it that way. Maybe it's like you're deploying something and it's only got a short lifespan and you'll just have it automatically pulled down. The other thing we can do with environments is we can restrict which branches are also able to push to them, or more accurately, which are able to interact with them. Because an environment is a conceptual construct inside of your repository. It doesn't have to represent environments inside of your infrastructure. It doesn't have to be dev, staging, prod. It could be if you're doing a deployment to like NPM or to like another package registry, you could represent those as environments as well. And you can have approvals on who can approve a release of this package to NPM or to our internal package repository or whatever it might be. You can set that up. And like I said, they're still classed as environments because they're places you are targeting. So we can restrict the branches. So if we're doing a branch strategy inside of our Git repo where we use like a release branch, like release/star is what we're defining as each of those releases. We can say that only pushes to a branch that matches this pattern will be allowed to then get into that particular environment. So there's a few different ways that we can cut and slice this all up. But that for the focus of this talk, I'm going to be talking about protection rules, specifically the approver-based protection rules. Okay, so let's think about how we can create a release strategy. So we'll go like, if we look at back originally what we had, we have this event, build, wait, deploy. Like that's the kind of basic life cycle that we've got. And I want to apply this to an open source project. How do we deploy something to the NPM package registry? Because that's something that I do, and it's something that is quite applicable to a lot of scenarios, is how we deploy reusable code across environments. So the first thing we're going to need to do is kind of break down our workflow into a couple of different stages. The first thing is I'm going to use tag-based rather than branch naming as the way to indicate that we've got an event that's happening. So we're going to push to a particular tag. This is going to trigger off a build phase within inside of our workflow. It's going to do a git checkout. So obviously we're going to need our code so that we can build, test, etc. And then it's going to create an NPM package so that I could ultimately deploy that into the package registry. But it's also going to create a draft release within inside of GitHub so that I can have that visible inside of my GitHub repository. Next, I'm going to break into the middle of that, and we're going to wait for that approval to happen from, well, me, because it's my own open source library, but you know, whoever is going to be the applicable person here. And assuming that we get the big green tick of approval, that's going to trigger off the next phase of our workflow, which is the release, where we're going to grab the package from the previous steps and then deploy it out to our NPM, GitHub packages. We're going to mark that release as approved, so on and so forth. So let's have a look at how that works in action. This, again, there's the link to the particular repository that we'll have a look at, and the QR code. So don't feel like you have to manually write them down. I'll share these again after the fact. But we're going to jump over to my browser here. And here I have an exceptionally zoomed in version of GitHub. Excellent. Hopefully that is adequately readable for everyone. And let's start having a look. Actually, let's start and have a look at the environments that we've defined. So to define an environment, we come into our GitHub repo. You will need to be an admin for the repo, by the way. So we come into the repository, we go to settings, scroll down to environments in the left-hand side here. And we'll see that I've got two environments that are defined. We've got the build environment and we've got the release environment, mostly because naming things is hard, and that was the names that I figured I'd come up with. If I click on release, it's got protection rules on there. We'll see that it's got a required reviewer, and the person that requires the review is required from is me, because it's my code and I trust myself implicitly. Now, how do we tell our actions to use those environments though? Because this is just something that I click through the GitHub UI, and I can create as many environments as I want. I create, let's call serverless Sydney. I can create this whole new environment, and ta-da, I have a new environment. But how is it usable? How do I get my action to be aware of it, that it needs to be used? Well, we do that by setting an environments node inside of a job in our GitHub workflow, GitHub Actions workflow file. So this is the build job. And inside of that, I provide an environment node and then the name of the environment. Unfortunately, this is kind of a little magic string-esque. So you've got to like name and case it the same way as you named and cased it with inside of the UI. It's like kind of an implicit relationship, not an explicit relationship. You just kind of got to, well, you'll find out pretty quickly if it's incorrect. The other thing we can do is we can set a URL for that environment. I'll come back in a moment to just talk a bit about what that is. But that's really all we have to do to set up the way the environment works. This has then got steps that it's going to do. So this is going to, as I said, check out our code. It's going to create a release. It's then going to run NPM steps to build, lint, pack, etc. This is then going to upload the artifact to the GitHub release. It's going to upload the artifact to the workflow as well, so that I can get to that later and just make sure that if I wanted to test that locally, I could download the package and do a local install before it actually ends up in a package registry. And then if we come a bit further down, too far, we have a release job. So this is what is actually going to publish it to the package registry. It's going to create the GitHub release and make sure that that's marked as approved and all that sort of stuff. This one is then tied to the release environment, and it does all the appropriate steps that it needs to do. Now, I said environments can have URLs. This is sort of like some output you might have from an environment. For an environment from a job that's run. And the reason you might want to do that is, let's say you are doing kind of like a dev stage prod setup, and maybe you want that URL of the deployed version to be available for people to test against. Well, we can do that by setting the URL property to a variable that's generated as an output from a task that's happened within inside of our job. In this case, I'm looking at the step with the ID create release, which is this one here. It has an output, which is the HTML URL. So that's the URL of the release that was generated when the workflow ran, and it created a release, and that's so that's where that one is. So I can click onto it. The way this works is that, the way this appears, so this is a completed run. We'll see that here is the build, there's the URL that was generated, there's the release, and then the publishers are doing a separate step. We can see there we go. No, scroll down. There we go. The deployment reviewers. So it was reviewed by me on that date for that environment. I didn't give it any comments or anything like that. So let's trigger off a new release. I'm just going to git add. I've just done some line ending changes to a file because that's the easiest way to do something. And let's just do a version bump. This is the joys of it being my own open source project. I can do whatever I want to it and cut releases whenever I need. And then we'll just do a commit bumping for demo. And then we'll do git tag. Oh, that's right. I have lovely white space line endings and all that kind of stuff. I am just going to do something a little bit dodgy and .git. And we're going to, I have some like Git hooks that are running and I'd forgotten that they were there. And I last used this on a repo that had Windows line endings and now it's on Linux line endings and it's really quite annoying. So let's just get rid of that. Done. Let's hack my own code base. Ta-da, look at that. We get rid of errors very easily doing that. And then we're going to git tag vo.1.5. That was what version it was. Yep. And we'll git push tags. Okay. So hopefully my live demo is going to work as successfully as I want it to work. Excellent. So that has pushed. We'll come into actions and we'll see that we have that triggered by the release. The way that I'm doing that is that it's doing a push on tags that match V star. That's how it knows to run on that scenario. So this is kicked off. We're doing our build step. It'll take a few seconds while obviously it grows the source code, runs the appropriate NPM steps, and there we go. Excellent. So now we'll see that it's, I've got this notification here saying that I'm requested to review a deployment to said environment. We'll see that our workflow is now paused with that a little icon indicating that it's waiting for something. I will receive an email shortly that tells me that I've been assigned as a reviewer for a deployment. This URL, I can click on that and it takes me through to the draft release that was generated for my the push that I've just done. I can click review deployments, select release, and put in a comment. I go, hello, Serverless Sydney, and then we'll approve for deployment, which will then kick off the rest of our workflow. And that will end up deploying to the GitHub package registry and NPM, and there is no changes that have happened. So it's all going to be very exciting for the few people that are using that node package that I've created. So that was what I was looking to cover off today in this talk and show you how you can set up a proper gated release process using GitHub Actions. We've seen that we can use a workflow inside of GitHub Actions to respond to events. In this case, we're looking at the events around pushing to a particular repository, but those events could be a lot of different things. It could be that you manually create the release, and that is what's going to trigger off the process to do that deployment. That's entirely up to whatever's the right workflow for you and your sorts of projects. We've seen how we can create environments inside of GitHub that represent constructs that we have around the way that our project needs to be managed, and that we can then tie jobs inside of our workflows to those environments. We've seen environments can have protection rules, and a protection rule could be that we're waiting for an approver to approve a particular release, or it could be that we're waiting for a certain timeout to have happened. And we can see that environments can be used to represent whatever the deployment task that we're trying to represent is. In this case, it wasn't even deploying to some kind of infrastructure-based environment. It was deploying to a package registry. And I could have set up the Github package registry and NPM package registries as entirely separate environments and kind of control those releases really fine-grained if I wanted to. But that's kind of overkill for what I need for my own personal open source projects. Might be applicable in other scenarios. thank you for having me on. As I said, I'll share out the links again on Twitter and tag the appropriate Twitter account so that they can be reshared. But I hope you've learned something. I hope you've enjoyed the talk. I've seen that I've got a bunch of notifications, which I'm assuming are the chat. But I've got some time for questions. I also have some Azure passes to give away if anyone asks a really good question or a question that I just really like someone having asked me. But yes, thanks again for having me. And let's check out what's happened in chat. I will stop screen share though.
All good. Thanks so much, Aaron. You're welcome to, I guess you're on a single screen. You can't screen share and check the chat. If you wanted to just leave up your either which way, all good.
Yes, I suppose I can do that.
But yes, I forgot to mention that you've got those Azure passes to give away, so that's really exciting. Just like the stock standard question that get asks if you're an Azure person is Azure DevOps versus GitHub Actions. Both do CI/CD pipelines. Why should you use one versus the other? And is there any sort of major difference between one versus the other?
I said probably is there any major difference? No, I mean, and you can put the same argument towards would you use Travis CI or Circle CI? A lot of these tools do very much the same sort of thing. So is one better than the other? Better for someone's definition, yes, and not better for others' definition. Which one do I use? I tend to use GitHub Actions for a lot of what I do, just because my code's already in GitHub. So I then just have everything in a single location. So if you are already using GitHub, then I'd encourage you to at least check out GitHub Actions and see if it will sort out and solve the sorts of things that you're attempting to solve. But if you're using Azure DevOps as the place that you're storing your source code, then Azure Pipelines is going to do exactly what you need it to do. Where I see some of the major differences are going to be is the kind of marketplace, for lack of a better description, of third-party tasks for what you can do. The GitHub one is very much designed around just grab something out of GitHub. So to use an action, you point at a user or organization / repository name. So it's very easy to publish custom actions that someone else could consume. Where in Azure Pipelines, it's a little bit more difficult to do that sort of thing. But in the same breath, it means that you've got the ones that are available for Azure Pipelines are probably have had a lot more investment put into them than I could write an action today that I could throw out very easily that I might completely forget about and have a glaring security hole that I'm not paying enough attention to, and someone hits along the way. So there's pros and cons to the two of them. I tend to use GitHub Actions mostly because my code's already in GitHub, so it works in that sort of a workflow. But that's not how everyone else is going to work, obviously.
Yeah, that's really good. Yeah, it's just kind of, I guess, part of the answer is just whatever you're comfortable with, where your code's located and that sort of thing, and a few perhaps enterprise grade considerations is kind of what I'm hearing as the summary, I guess.
Yeah, and up until we had the environment relationship, it was we didn't really have that release story very well nailed down. So it was really difficult to suggest, particularly from an enterprise standpoint of I want to have someone it's deployed in the staging environment. We're going to smoke test that. So we're going to wait until the QA lead has at least verified you can still log in before we deploy to production. Yeah. You don't want those kind of regressions just to pop up because you missed in automated testing. Yeah,
absolutely. Well, that's a really cool walkthrough. I think really appreciate. I think it's CI/CD is obviously a really important part of any sort of application development pipeline, and GitHub Actions is just, I think its ease of use is contributing to its massive popularity. I think going through the chat, there was just so many folks that have already given it a go. Maybe not used it in production, but I've got a couple of GitHub on the AWS stack. I've got using cross account roles, from my like shared account through to like dev, staging and prods. But, I'm always just a little bit worried because I've got like this user with a set of keys. You're assuming the cross account roles and stuff like that. And it's just like, oh gosh, if someone gets a hold of that key, then there's probably going to be a lot of Bitcoin mining happening on my account or something like that.
Yeah.
But I'm guessing it's probably a similar. Is it a similar story on Azure or?
Yeah, look, you can quite easily make some glaring security holes if you want to in a CI/CD pipeline. A lot of it comes down to how much thought you're putting through who could access it, like who can run arbitrary code in it, like if you're and what is the elevation of privilege that someone has when they're running that arbitrary code. It's awesome that I can just write something that is going to execute in a bash shell, but who's that running as? And if I'm doing self-hosted runners, so they're on my own infrastructure, who are they then running as, and what can they do? That's where you've got to really be careful.
Yeah, no, fair enough. We've actually got a few questions through on the chat, so I'll just read them out to you. Question from Dimi. Any recommendations on scenario where like .github workflow star is maintained by a separate CI/CD team or actual source code by developers? How to segregate those two as effective pipeline definition in the same repo as the application code? So I guess you've got a CI/CD team that's maintaining the GitHub workflows, and then maybe an application team's downloading that as a template, and then they're developing the application code, sort of that separation of teams.
Yeah, I haven't tried it personally, but you may be able to do it with submodules as a way to include them. My only reservation on that is I'm not sure whether the submodule resolution will trigger off the same, make the events available, because technically the code's not part of that repository. And the thing you want to be careful of with workflows like this is you don't want someone else to be able to just inject stuff randomly into the way that your repository works. It's kind of going back to that comment I made before to you there, Peter, about you got to have this level of trust of who's there. That sort of scenario I think could be quite difficult to tackle without having kind of like a two hop process of you've got to pull it in from an external repository and then put those raw updated files in. Like maybe it's a submodule with a cron job that syncs them across to the .github /workflow folder. But yeah, I'd also be interested to understand more about what would be the restrictions why you wouldn't have everyone working with inside of the same single Git repo, even if one team is owning part of that repo and another team's owning another part of it. What things are limiting you from all just working with inside of the same Git repo anyway? Other things that might catch you out is that, at least as far as I've been able to find, GitHub workflow files don't support sort of like being split out into multiple separate files. So this is something that I could definitely do with Azure pipelines, and I haven't found that I can do it with GitHub Actions, where I basically create like a workflow template file that just lives somewhere within inside of my repository, and then I would do, for lack of a better description, like an import statement to bring in that, and then like that YAML chunk would just get dynamically consumed as the workflow was being constructed from the file. I said I haven't found that we can do that with GitHub Actions yet, but that could also be from lack of discovery on my own part.
Yes, and I was just having the thought, perhaps you could use some GitHub Actions that you could share. Develop your own GitHub Actions within the team. The DevOps team would develop them. That could be utilized by the actual application development teams. Can you create private GitHub Actions, or are they always public by default, or is that one for the docs?
Private ones within inside of an organization, I think, are going to only be usable from other private accounts.
Yeah.
I know that there's some stuff around the way that private is handled a little bit differently. And I can't remember whether it's workflows inside of private repositories or private repositories or public repositories accessing private actions. The easiest kind of shortcut around, like, if you don't want to share out the way the action is implemented, is to bundle it as a Docker image and publish that to a Docker registry that only something other than like Docker Hub, and then your credentials to access the Docker registry are then provided as secret variables to the workflow when it's run. So theoretically, like the image is publicly accessible, but you need a set of credentials to be able to access it from the registry that's accessed on, and then your repo's workflow has those credentials and can access them. Yeah.
Oh, that's that's given us plenty of food for thought in terms of how to sort of, I guess, make it a bit more sort of, enterprise ready in terms of, say some of the more complicated use cases or more demanding sort of DevOps teams and stuff like that. So virtual round of applause to Aaron for coming down and yes, amazing.
Too much applause there.
Yes. No, we'll worth it. Thanks again. Once again, really cool. And looking forward to seeing a bit more of you perhaps later on in the year, and good luck with your workshop today.
Cool. Well, thanks again for having me. Dimi, if you want to explore the kind of problem that you've got more, feel free to just shoot me an email. I'd love to understand a bit more about it and see what we can do to make sure that GitHub Actions can do everything that you need to do. Partnered. All right. Up next, we've got, thanks, Aaron. Cheers. Up next, we've got Yunji Lin. He's a partner at Deloitte now, and he's going to be taking us through Lambda Containers, which is pretty exciting. One of the releases from reInvent last year. So take it away, Yun.
All right. Thanks, Peter. I'm going to share my screen. Yeah. Well, thanks, Aaron, as well, for that awesome talk about GitHub Actions. It's really good to see all the investment into GitHub Actions and GitHub Enterprise as well. I personally use it quite a bit as well as my teams on client sites. And we just really are seeing quite a lot of exciting features just coming up in the pipeline and the roadmap. So today, I'm going to talk to you about AWS Lambda Containers, bridging the gap between serverless and containers once and for all, right? So I'm sure a lot of you have been sort of hearing debates and stories around, should we use serverless, should we use containers? Why not both, right? So that's a proposition I want you to have a think about, and hopefully you walk away today convinced that you can have both and they can live harmoniously side by side to achieve your outcomes. So my name is Yunzi Lim. I'm a partner at Deloitte Platform Engineering. So a bit more about me. Interesting fact, my name actually means cloud in Chinese. So Yun is cloud. so what I do, cloud. So I'll tell you a bit more about Deloitte Platform Engineering in a moment. But I've been sort of dabbling in serverless way back when 2016. And I started working with containers around 2013, 2012, 13-ish. So it's quite interesting. I have quite a different perception of serverless and containers to most folks, because when I used to use containers, there was no Kubernetes, right? So we had to hand roll orchestration, hand roll cluster management. Whereas nowadays, it's very different. And I think a lot of time when people think about containers, they straight away think about Kubernetes. And I'll present my sort of paradigm on that in a moment. I wrote a library called the Serverless Golang back in the days when Lambda didn't support Golang. So I wrote my own library to do that. And within that year, AWS actually released official support for Golang. And there was a bit of an infamy back in 2018 where I did a Lambda benchmark, and .NET actually came out top, right? So I pretty much started the entire holy war about how can .NET be so fast? And then all the .NET people rally behind me saying, yeah, .NET is the way to go. But yeah, that was interesting. And you can sort of read up about it in the Cloud Guru's blog. Yeah, you can find me on Twitter, UNZLin, or LinkedIn, Mr. Serverless. In the past, I've been quite active in the serverless community, speaking at the Serverless conference in New York, Sydney Serverless Days, which is actually where I met Peter face-to-face. And also frequently speaking at the AWS Summit when back in the day we used to physically go to conferences. I myself am certified, so I do know what I'm talking about. And I do sort of still get into the code every now and then. And then that kind of makes you wonder, right? A partner at Deloitte, what does a partner do? It's quite interesting. This is actually what people think I do a lot of times. Like if you kind of ask people, what does a partner in Deloitte do? They go, guys in suits and very presentable. They go out there and sort of talk to clients. But in actual fact, this is more like what I do day to day. I'm still there out on the front lines. Every project I'm in there sort of helping the team and also interfacing with the clients. And I get my hands dirty myself, right? One of the values that we pride ourselves in is very much the whole lead from the front. And that kind of comes in both the technical perspective as well as the leadership and business perspectives. All right, so enough about myself. In terms of the agenda, I'm going to go through with you why serverless and container matters, and why you should consider using them in conjunction with each other. How do we actually implement serverless kind of containers, and how do we migrate existing containers into a serverless paradigm? There are certain pitfalls to watch out for in the current implementation of Lambda containers. And hopefully by the end of this, you can go forward and make containers great again. Yeah, feel free to sort of shoot through any questions. I can't see it on my screen, but Peter, like at the end of each section, I'll take a pause and, let's have a conversation. And also feel free to yell out as well, because I was just saying to Peter and Aaron, in this current situation, that's one thing we miss is dialogue and conversation, right? So if you have questions, I'm more than happy to have a discussion. Yeah, so tell me why. Every time I ask the question, tell me why, this picture pops up in my mind. And kind of showing my age, right? Backstreet Boys in the day was the song Want It That Way. Okay, so before I kind of go into the why, what I think is why it should matter, maybe we should do a poll, right? So how many people in the audience actually use serverless in Anger in production versus containers in Anger in production? So Peter, if you can bring up the poll.
Let's do thumbs up and down. We'll just count how many people do thumbs up and thumbs down.
Right, let's do that. Okay, I might put on the what's the view? Thumbs up if you use serverless technology in Anger in production. Oh, 1, 2, 3, 4. We got 4.
What's happening? Yeah, it's a few. Couple.
Got about 4 to 5. Okay, I mean, thumbs up if you do if you use containers in Anger in production. This is a bit of a loaded question considering we're at the serverless meetup, right? So,
yeah, it's going to be a bit of a skew.
Yeah. All right. So I guess, I mean, I was kind of, the results is not that dramatic, but it does show that, to some extent, out of all the hands-on developers that are out there working with your various organizations, serverless and container are quite sort of go hand in hand, and it is very much horses for courses and using the right tools for the right job, right? So there is definitely use in most organizations for both technologies. And one of the sort of news flash I just realized recently is that as of the 9th of February, Lambda Containers actually supported in Sydney region, whereas back in reInvent, when it was first announced, it wasn't quite available in the Sydney region. Okay, so there's actually a lot of debate. In my previous company, we've been involved in some of these debates. my friend Faris Brazil, he's debating about serverless versus containers soon. And there used to be a serverless versus containers wrap with Faris Brazil as well. But what I kind of realized as I read more into these sort of debates, serverless versus containers, are mostly debating about function as a service versus Kubernetes. It's actually not necessarily serverless as a methodology versus container as a abstraction for infrastructure, right? So if we kind of unpack that a bit more, serverless is actually not function as a service. If you think about the serverless paradigm, a database can be serverless, such as Dynamo, right? Storage can be serverless because you do not pay for anything apart from the storage itself. You do not pay for the servers, you do not pay for the compute. And GraphQL can be serverless, and even AI can be serverless. You just basically call the API, and then you get a chatbot functionality or some sort of translate, transcribe, etc. Whereas function as a service actually is somewhat intersecting between what's serverless and what's not, right? Lambda is serverless because at the end of the day, you don't pay for it. If you don't use it, you don't need to worry about scaling and you don't need to worry about servers. But open source technologies such as Kubelet and Knative can be done in a serverless fashion if a particular vendor is offering the pricing and the cost paradigm for you not to pay for them when you don't use them. But if you were to hosting them yourself, you end up having to worry about capacity planning, about the servers, and various scalings. Like it no longer becomes a serverless paradigm, even though it is a function as a service, right? So there are times when a function as a service can give the developer the abstraction to develop functions, but doesn't necessarily give you the cost benefit of what a true serverless paradigm should be, which is the fact that you don't have to pay when you don't use it, you don't need to worry about scaling up and down, and you don't need to worry about provisioning or managing servers. So with that in mind, let's think about containers, right? Containers is not Kubernetes, right? Kubernetes is a container orchestration platform. And to some extent, the container runtime itself in the form of CRIO. But containers, when you think about it, the bare minimum understanding of a container is just a way to package up your code and your dependencies and various source files to make an immutable artifact that you can deploy to Kubernetes if you wanted to, or you can deploy to a microkernel or micro VM, such as Firecracker. And there's actually quite a lot of implementation of the container runtime that has been open source in the form of Containerd as a standard. And there's actually various different implementations other than Docker that implement Containerd and the Open Container Initiative. So ultimately, container is just a way to make immutable, portable artifacts, right? So if you think about it that way, then serverless and containers actually make very good sense, because prior to having container support, what do we have to deal with? Zip files. Zip files are not exactly immutable, right? Whereas containers are. It gives you that sort of immutable infrastructure. It's portable because you can sort of run it on any operating system without worrying about the underlying dependencies, because it's self-contained, right? It's got all the dependency within the container. And if you combine the sort of immutability and portability of containers with the serverless FinOps paradigm, well, then you don't need to pay for the billing when you're not using that. You don't have to worry about scaling. It actually combines the best of both worlds. Hence, why not both? Lambda containers. It seems to be the perfect combination of both worlds. All right. So before I kind of get into the implementation and the code demo, any questions about the serverless and containers paradigm? Nope.
Feel free to just unmute yourself and just ask you a question.
Chat?
Hi, yeah, we've got something in the chat. Marek Petros, AWS Lambda container versus ECS Fargate. What's your opinion there, Yuan?
Yeah, okay, that's a very good question. Lambda versus Fargate. So if we kind of go back to actually potentially there's an icon missing, which is Fargate. But so this is something I'm not too clear on what's the latest on this. I recall back in the day, Fargate, there was an issue with scaling down to 0, which then makes it kind of, strictly speaking, on the spectrum of serverlessness, if you cannot scale down to 0, then you don't end up paying, like you don't end up with a don't pay for it when you're not using it. I think there is a way that you can make it scale down to 0, in which case it does conform with the serverless paradigm. But I do believe with the difference, the fundamental difference between Lambda and Fargate is really around the fact that Lambda is still very much a function as a service. So you can deploy Lambdas now with container support, whereas Fargate is still very much a cluster-based mechanism where it does scale up and down based on usage, but because it's a more of a cluster-based approach, it probably doesn't do it as kind of fast and responsive as a function would. That is sort of my take on things. Was there another question?
David Mitchell, he's just said more of a comment. The current PaaS model, while it's great, doesn't seem like it's the end game for serverless orchestration and state management for serverless areas where there's lots of change. It'll be interesting to see where these wind up. Fargate doesn't scale up particularly quickly. That's a key limitation for lots of use cases. And then Dimmy's chimed in with Lambda having a 15-minute max execution. One could argue, I guess, you're sort of building, like there are sort of, I guess Fargate's a little less event-driven as well. You could argue, but, maybe you can have implement a long-lived API in Fargate. So, but sorry, I'll stop chiming in.
No, I think you're right. You're actually kind of spot on there, Peter. I do feel like the paradigms are sort of converging a bit. Like if we think about the serverless paradigm as a generic sort of 3 principles around not paying for what you don't use and scaling up and down, and also not managing servers, whether it's a cluster-based approach versus a function-based approach, whether it's long running or short running, how fast it spins up and down, it almost is becoming more of a sort of billing paradigm. Like there's no reason why Lambda cannot run for half an hour or 1 hour, right? But it is very much imposed upon you by the billing structure of, well, we wanted to shut it down so that we can sort of share the pool of compute with other users, etc. But I believe they might have increased it from 15 to a bit more. I can't remember the exact number. But yeah, and this is kind of where, yeah, there's actually it's not a physical compute or server limitation for Lambda running 15 minutes, right? It's somewhere along the line, there was a decision made to say this is the most cost optimal way for us to maintain a pool of compute, which can serve the greater needs of our clients and be able to also conform with the billing structure that we have. But if that was sort of then shifted, then it can very well be, well, why can't we run a long running function, right? Or in the case of like, there was a lot of conversation back in the day about and concern about cold starts, but that has since been eliminated with the provisioned concurrency, right? Once again, that's a billing concern, right? It's not that in the region in Sydney we don't have enough concurrent like compute to run Lambdas. It's more so that, well, how much can AWS charge as a premium to keep the concurrent Lambdas running to meet your needs and also your economic sort of budget thresholds. So yeah, I do think it's very interesting. Yeah, the two worlds sort of coming together, and it really does sort of point more to the way that a container does seems to be a unit of deployment and artifact packaging of choice for most developers, and the serverless paradigm really flies really well in the container with a container lens to it. Okay, let's move on. So let's look at some code. Okay, but actually no, before we look at code, let's actually look at the anatomy of a Lambda container. So there's two ways about it. You can approach this problem. you can either start from scratch with a AWS-based image, which will contain all the runtime interface and also the emulation that's needed to run it locally. It's probably the easiest way. So if you were to implement a brand new greenfield solution, this is probably the way you want to go, where you just use the AWS-based image. Or if you have some sort of compliance constraint around golden images that your company have to conform to, or if you're migrating off existing images, say from Fargate into a Lambda, then you might consider the sort of BYO approach, which is you then have to install the runtime interface client to actually be able to translate the AWS events into something that your code can understand. And you then also need to consider the runtime interface emulator, which allows you to run your containers locally. Okay, and I feel like this is actually one of the key difference when you think about it compared to, say, which is another popular alternative with Google, right? The Google Cloud Run, which is a sort of container runtime that bills you by the second of how long your invocations are actually lasting, but it only takes HTTP events. Whereas with the sort of Lambda container ecosystem with the runtime interface client, it can actually translate the AWS events into code that you can understand. And that way your Lambda, even though it's running a container, can pretty much be triggered by and also interface with all of the AWS ecosystem of events that a normal Lambda would have access to. So yeah, I do kind of find that quite interesting in the range of support in terms of the event-based triggering, Lambda container. All right. Okay. So let's jump into the code. Similar to Aaron, I also have a little open source project I put together for this demo. If we don't have enough time to cover through all the things you want to look at, you feel free to hit up GitHub, serverless cloud / serverless containers. What I'm going to show you today is a version using serverless framework, the popular serverless framework, and also the AWS native SAM framework, right? I built a pretty quick and dirty example using Java, Node, and Golang. I think probably that kind of covers all the hipsters, right? From the traditional Java folks to the the cool kids using Golang. And yeah, we're gonna want to try to build and then do some local runs and deploy things. All right, let's get into the code. And here's the code. Any preference? Which one? Okay, let's just go to Node.js first, right? Nothing fancy, right? Every time I do demos, people go, "Oh, why don't you give us a real world example?" But what is a real world example? I can't really find a real world example that will cater for everybody, so I would just go for hello world. So yeah, nothing to see. Your basic return 200 status code and give you a very simple message. So that's the Node code that we have. And this is the serverless framework example, by the way. If we go into the Docker file, it's a pretty standard multi-stage Docker build. Or is it? No, it's actually not. I lied. It's not multi-stage. It's actually using the base image and then installing the entire universe with the npm install, and then setting the command to be the hello function. All right, so let's try to build this. Okay, I got my Node.js. So something I like to do is kind of typically wrap my commands with makefiles. I am a big advocate of this methodology called Three Musketeers, which I co-maintain with a few friends. This is actually not the full Three Musketeers approach. This is very much just a makefile that wraps around the commands. But if you're interested, check out threemusketeers.io. Yeah, it's pretty lightweight methodology for getting started on new project really quickly. Okay, so what I'm going to do is just go make build. Make build. The security token has expired. Okay, so let's do a log in. What did I call it? All right, there's no credentials here.
Use AWS SSO for your cross-account role assumption as well. It's pretty nice.
Well, it's I think it's all right. Yeah, like I do find it a bit confusing compared to the old IAM and the old sort of switch roles where you just have this single URL and you click and you go. But like now I have to go into this GUI. Yeah, I don't know.
That's the other thing.
I'm having mixed feelings about, I got to go to this GUI and click it. Yeah. But then what's really sort of, what makes it more confusing for me is if I go into the manage console and then I hit switch roles, it takes me to the old screen. Right, so like you would think if I kind of come in through SSO, it should take me back here to, but anyway. All right, okay, I'm logged in. Okay, I should be able to build then. Okay, the reason why I have to log in is because as part of the build, okay, obviously everything's cached. As part of the build, if I look at sort of my target, it needs to run the ECR authentication, which is this long command. And that's why I need to sort of log in with my SSO so that I have my temporary credentials. And with my temporary credentials, I get myself a Docker login. And with my Docker login, I can actually build the image and push it to ECR registry as well. Okay, so that was my sort of image, which is the very long ECR URL and my AWS Lambda Container Node.js image. If I look at my local image repository, I do see it. Actually, where is it? 54 minutes ago. Okay, I don't think did it actually build anything? Let's have a look. Oh, the timestamp is not in Australian timestamp. But yeah, I mean, here's my image. Yeah. So, yep, that's my image. 1216. Yeah, anyway. So yeah, that's building an image. And then what happens is once the image is built in my serverless YAML, so instead of previously you would have put your functions in as a definition within your YAML, you would now then put the image, which is the same image that I just built. And as I mentioned before, you still have access to all the various events, right? So aside from the fact that you're now packaging your code as an immutable artifact in the form of a container image, nothing else has changed from a Lambda perspective. You still get the awesomeness of the various events that you have access to, okay? And if I were to try to deploy it using my make deploy, which is just calling serverless framework to deploy, profile doesn't exist. Okay. Yeah, so this is a bit where I need to kind of play around with my credentials because the serverless framework doesn't support AWS SSO. And what I need to do is actually go and into command line and copy.
You should be able to actually get them if you click on the account that you're deploying to. Yeah, you should be able to copy that. So.
Yeah, so I need to copy this, right? And then you now all see my credentials. Yes. So anyway, it works, right? Trust me, because I know it does deploy. I do have the Lambda deployed. Yeah, so so that's a Node.js, and you notice the name is very different, right? Because the convention with serverless framework is that they put the environment at the end, followed by the function name, right? So it's the service name, environment, and then function name. Whereas with SAM, you have more control to actually. I personally like to put the environment at the front, right? So I can sort of specify that with SAM. But yeah, here is my deployed Lambda, and I can find the image, and I can actually link to it as well. So if I click on that, it actually takes me to the image, which, yeah, that same image that we had. Okay, so now if I wanted to run this, what did I call it? But because I don't have the right credentials, I can't invoke it either. Okay, anyway. Okay, so I got credential issues, which I'm not going to try to fix right now. But what I can show you is with the serverless framework, there is also a way of invoking your local function for local debugging. But at this point, the local invocation of Lambda pointing to ECR registries is actually not supported. Okay, so we can work around that though, because as I mentioned before, anything that's using the default AWS Lambda container images already have built in the runtime interface emulator. So we can simply we can run the actual image that we built, and it will actually act like a running Lambda container, right? So if I were to run this command that I had prepared, which is make run local, so now it's actually running the container that I built, and it's ready to listen to events, and it will emulate the events as if it's actually coming from the AWS runtime. Okay, so if I go to a different screen, what? Oh, right, okay. SLS, right, okay. Ta-da! I get my hello world message. Yay. So that's local development there. So as you can see, it's almost a bit it's a bit more familiar, right? The fact that you are running, like there's different commands to this. There's the SAM framework has a local kind of invoke command, and there's all these different wrappers. But fundamentally, what it's doing is really just running a container with a port mapping. And you can even hit this if you wanted to, right? You can even hit this, except it's gonna just give us will give us this result, unless we know exactly what to call. Yeah. So yeah, it's actually running the container locally, like you would typically run a RESTful API locally, and then you can actually start doing some testing, right? Obviously, I mean, I have a hello world example, and then I don't really have like a RESTful payload, but if you sort of set this up properly, it's almost as if you can have a normal development lifecycle the way you would do for a container workflow. And then the only difference is you deploy to a Lambda by the end of it. Any questions so far?
Just a comment. That's really cool. I think that's going to, waiting to deploy something to say US East 1, 5 minutes or something like that, that just completely disappears with that workflow. So that's really cool. Yeah. Enrico Simonetti, he's asked, personally, I use Docker for development purposes, not production. I looked at the serverless framework a while back and played with Lambda standalone for specific requirements. I would consider myself relatively clueless about this whole topic. What resources do you recommend as the starting point to allow to learn more and be able to build a new stack, a new application with today's tech stack?
Yeah. So Enrico, I think I take the question as in the stack that's kind of being demoed around Lambdas and containers. I do see there's a few folks posting answers to this as well. I have a bunch of links as well in the end of the slides, and I can share with you. I think you can also feel free to check out the code that I have in the open source GitHub and sort of kind of play around there. It's all pretty intuitive. Yeah, it's
A Cloud Guru, shameless plug for them. They've got some really cool courses on, how to get started with serverless, building some applications that kind of give you a bit of a feel for event-driven architectures and things like that. Full disclosure, I used to work for them, and Pete Sparsky, the creator of this Meetup, is VP of Education there. So, but yeah, they're pretty good if you're just trying to get started.
Yep. Yeah, I can see in the chat that we're talking about ECRs and the same account restriction. Okay, we'll get to that. Jumping the gun, but it's good. It's good to have the discussion. So what am I doing? Okay. Okay, let's get out of Node.js. Let's go to the hipsters. We go to the Golang world, and it's pretty much the same thing. A very standard Golang project. But this time it's we're using the SAM framework. We're using the SAM framework from AWS native, and one thing to note is that the beauty of the SAM framework, what I find is you can pretty much run SAM init, and it can set up everything for you. See, do you want a zip or image? Of course we want an image. Why do we want a zip? But you get to choose now which sort of base image you want to use. Let's be funky and use Ruby, and my Ruby app. And see, this is really cool, right? Now I have a Ruby app. Yeah, so the scaffolding actually works really seamlessly, and it kind of gives you everything you need. But there's one thing to note here, right? It's if you look at the actual template that they give you, it defaults to building the image as part of the template. So what you have to do is that if I run SAM build, it builds the image on the spot, and I don't really like that. I just think, SAM should do SAM. SAM should do serverless and AWS things, and then let me do the Docker things, because what if I have a different lifecycle for my Docker build, right? So I'd rather sort of just comment this out, and then like I did with the Golang, I commented it out, and then I just put in the actual the image URI. And I was lazy, I had to put laters, but typically you probably want to be doing something like, I don't know, something like that, right? Yeah. Okay, so that's the SAM framework versus the serverless framework. Maybe I'll just go back to the slides now. Anything else particular I wanted to show? Oops. Why did I do that? Okay. Build, deploy. Okay, so let me try to deploy for the SAM framework. I have it here. Yeah. So as you can see, because the fact that SAM is more native, and therefore you get a lot more sort of messages that are very CloudFormation centric, and the same, my stack is up to date. Yeah, so one fundamental difference, if you are familiar with Serverless Framework and SAM, is the fact that Serverless Framework will create multiple stacks for every single deploy, and then SAM will continue using the same stack. So there's no changes in the stack. It actually doesn't deploy. Yeah.
Just a comment there. I think the problem there is the latest, because if the version number doesn't change every time, there'll be no update on CloudFormation.
Right. Okay. So let's be brave and try. This. That was fast. Did I actually push anything? It did. Okay, it pushed one. Okay, all right. And there we go. Yeah. So that's good. Thanks for the call out, Luke. Yeah. So now, because the fact that I have version 1, even though it's the same image, thus it got tagged to the same image with later than version 1, but because the cloud formation has now changed, it creates a change set and it deploys. Okay. So, and then one thing I also wanted to kind of call out is the fact that with SAM, it also has a functionality to do local invoke, except local invoke actually does work with containers in SAM. And with the SAM examples in particular, there's actually is the API gateway, so we can actually call the API gateway and get ourselves a hello message, right? And if I wanted to do it locally, I can do a make invoke local, which really is just calling this command. And it gives me the same hello, right? Okay. Let me jump back to the slides. Do we have any other questions online? What are folks using to deploy code? CDK, serverless, or SAM? Yeah, good question. Let's hear it. All right, we'll leave that one running. Okay, so pitfalls to watch out for, and I think the folks on the chat have already pointed this out. Okay, what's wrong with this architecture? It's pretty. Any takers? We got 3 accounts and we got 3 sets of ECRs, and then the same image is deployed to all 3 ECRs and put down by the Lambda. So shout out. Oh, everyone is still responding to the poll. But yeah, I mean, we know this is not this pretty much goes against everything that containerization immutable architecture stands for, right? Because even though it's the same image, every time you push to a different repository, it's effectively a mutation of some sort. Whereas what typically should happen is that you would have a more centralized ECR, which is the source of truth, and that same image in its immutable nature is pushed to each of the accounts. And if something breaks in any one of the environments, you would know that to debug against that particular image for that particular version will guarantee you the same immutable environment as the environment where it's actually broken. But you can't do that, right? You can't do that in Lambda at the moment because the image repository has to be in the same account as the Lambda. I believe Evaluator 6 already pointed it out. Yep. So yeah, watch out for that one. And it's also kind of good to compare with other offerings out there with the Google Cloud Run, which it seems to be more of a cluster-based container serverless runtime, except it only takes HTTP events. But even though it's a cluster, it only charges you for the length of your invocation. So when the cluster is coming up and the cold start, you don't get charged. See, once again, it's kind of pointing to that billing paradigm, right, of serverless compute. And I find the Azure functions on Kubernetes actually quite interesting, using the Kubernetes event-driven auto-scaling. And stay tuned on this one. I think one of my colleagues, Aaron, will be giving a talk on this coming soon, and give you a heads up as well, Peter.
Awesome.
Yeah. Yeah, so kind of my sort of quick hacking around was I haven't used serverless framework and SAM for quite a while, actually. But my sort of immediate feeling is I do feel like the AWS innovation is just really outpacing frameworks. Like sometimes when having abstraction over AWS native APIs, there's always a bit of a lag. Even though both serverless framework and SAM already supports containers, I do see that, well, you know, SSO is not supported in serverless framework. Is, for example, as part of the scaffolding, you don't get the nice container templates. You don't get the nice local run either. And on the SAM's perspective, I feel like they're probably doing a bit too much. Like, why do you really want to wrap around Docker build with SAM, right? Because that's not the kind of goes against the single responsibility principle in my view. But yeah, SAM seems to be a lot more well integrated at this point right now, if you wanted to go down this path. And I think with that, we can segue into the answers to the poll of who's using CDK versus SAM versus serverless. We got two serverless, 2 SAM, and 1 CDK. Pretty close one, huh? All right, so with all that knowledge, let's make containers great again, right? Why? Because serverless first is the way you should go, right? According to Adrian. Adrian kind of presented this back in 2018, and he has a whole series of talks and videos on this. Is the fact that if you're going greenfield, try serverless first. And if you have to, then transition back to containers. Well, guess what? That's now much easier because you can deploy serverless first in a container format. And if you wanted to transition to Fargate or EKS, you still have your container, right? You just have to change the base image. And if you wanted to do app modernization for your existing workloads or legacy workloads, well, if they are containerized, you can pretty much port them over, install the runtime emulator and the runtime client, and off you go. Fingers crossed. So kind of main takeaways away from this talk is really remember that serverless is not fast, right? Fast is a subset of serverless. Sometimes fast is actually not serverless at all if you sort of deploy it on tin for specific reasons. And containers is not necessarily Kubernetes, right? Container can be deployed to Kubernetes, but container in itself is really just a standard for artifact packaging. Therefore, serverless and containers make sense, and it brings in a whole new level of developer experience where you can run containers locally and have your favorable familiar toolchain to do your debugging and testing. And as a result, it really brings a new paradigm to the whole serverless first transformation approach and approach for moving your legacies of sort of existing lift and shift environments into a more modernized sort of serverless environment. Okay, and here's some sort of references that I personally use as part of my research. You can find the code in serverless containers under serverless cloud. AWS has some really good articles, and there is a Cloud Guru article by James Beswick, which I found very useful. He goes through it step by step on how you can build a container Lambda, either from the console or using SAM. The serverless framework also has a blog, which I think I did post here. Oops, I missed that one out. I'll put it back. I'll put it in the slides before I upload it to LinkedIn. And the various announcements and the runtime clients, if you want to find out more about the runtime client versus the runtime emulator, you can find it in the links under the AWS section below. And with that, yeah, thank you very much for your time. And hopefully this sort of gives you some new ideas to bring back to your workplaces.
Well, thanks so much, Ewan. Yes, that's, like all the tooling and stuff like that that you took us through. I think that was really cool. Three Musketeers. I didn't realize that you're a contributor to that. Toby Heed of Amazem has spoken quite fondly of Three Musketeers in their dev pipeline, and I just wanted to call out before we ask any questions, because I'm sure we're going to all drop off pretty soon, but we'll run the meetup same time next month. And so if you're keen to present, I think you said that you've got a colleague that might put their hand up. That's awesome. Just feel free to ping me, peter@cloudshuttle.com.au. Always excited to hear, especially newcomers, first time presenters. So if you're interested, just, send us an email and we'll get the ball rolling. Any other questions for Ewan before we wrap things up?
I was just wondering if you had done any benchmarking to compare container-based Lambda functions compared with like regular Lambda functions.
Yeah, good question, Luke. And if you know me, I love benchmarking. I just haven't had the time. Probably will get. I might this time around, instead of actually just doing my own benchmarking, I might actually see if anyone else has done it, because I did find this one particular website which had quite comprehensive benchmarks for the. At the time when I looked at it, was obviously the sort of traditional fast benchmarking. But I wonder if they sort of already jumped the gun and had a look at the container base. But yeah, it would be interesting, right? Comparing the Firecracker-based container functions versus the Kubernetes-based Azure functions versus the GKE-based, I would assume, Cloud Run function, Cloud Run sort of runtimes, right? Is to see how they compare.
There was a paper I read on that probably last year that said the Azure functions came out considerably slower than AWS and GCP.
The GCP and the AWS sort of virtualization for the serverless functions was always somewhat superior. I always thought the Firecracker was probably one of the best ones. But yeah, with this now container paradigm, it seems maybe it's time for a refresh on the three.
I think also the choice of language comes into it as well. I've written a bunch of serverless code in Rust and Go, and it's much faster to execute than Node, Python, Java. It's just a statically linked language with no runtime associated with it.
Yeah, I can't keep up with you, Dave. I think my hipster limit stops at Go there. But I have yet to try Rust, but I have been hearing good things. And yeah, keen to see how you go with that, and maybe you can share that experience someday. So.
Yeah.
Cool.
One thing's for sure that's come out of reInvent this year is that you've got a lot of options on the table as to where you run your code and how you run it. So, which is pretty cool. I'm worried for you, Ewan. Your battery tests for measuring the latency and things like that is just getting bigger and bigger. You're going to have your Kubernetes cluster, across 3 different clouds, Lambdas, functions as a service, containers, all the rest. It's going to end up becoming a bit of a beast, but equally exciting to see how it plays out.
And I think this kind of goes back to our previous point around the worlds are converging, right? I think it's really just, at the end of the day, the abstraction levels is moving higher and higher and focusing on business value and outcomes. And a lot of the underlying abstractions around orchestration, clusters, is just kind of moving away. Even for folks who want to use containers, which most people do, now you can do it in a way where you don't have to worry about the non-differentiating concerns. Yeah.
Yeah. No, absolutely. Well, thanks once again. See you all next month. Thanks for dialing in. Hopefully you're getting a lot out of it. Feel free to send through any feedback to my email as well if you'd like to see some different content, or if you've got some great ideas on how to make this an even more engaging meetup. But I just thought I'd really like to thank Ewan and Aaron once again for just being awesome presenters, you know, putting the time and effort to put in live code demos as well. That's really awesome and really beneficial to the community. So yeah, ciao for now. Thanks so much, folks.
Thanks, Peter. Thanks for